So number one, a sample of the eating habits of high school football players were measured 2 years in a row. In the first year, the 400 players were sampled and they ate an average 1,360 pounds of food with a standard deviation of 261. The following year, 625 students were surveyed and they ate an average of 1,320 pounds of food with a standard deviation of 306. Is it safe to say that football players ate less per person in the second year? All right. So this is the first year. This is the second year. We have two samples, 1360, so that's an average, with an SD of 261 and a D of 400. On the second year, my average is 1360 with an SD of 306 and a D of 625. Oh, I'm sorry. 1320. Yeah, that would have been accept the null, right? If there's no difference, then accept the null. So for my SE, I'm going to take 261 and divide it by the square root of 400. And I get 13.05. So then, what? Oh, sorry. Sorry. Oh, I broke it. Okay, so that's what you guys were saying to me. You got me all confused. So now I need to find the SE difference. So the square root of 12.24 squared plus 13.05 squared gives me an SED of 17.89. What does that mean? Well, it means if there is no difference between the eating habits of the first group and the second group, then your differences will be about 0 plus or minus 17 pounds. So we need to compare our actual difference to 17.89 pounds. So I draw my normal curve and I put 0 in the middle. My actual difference is 40. So I take 40 and I divide it by the SE difference, and I get 2.23, which is going to give me a p-value. The area over here is like 1.2. Now, if I'm randomly sampling football players, what is the chance that I end up with a score that is 2.23 SEs away from the actual value? And the answer is 1.2%. Is that very likely? No. So we're going to say that the result we got does not seem the same. We reject the null, and we say there is a significant difference between the eating habits of the first group and the eating habits of the second group. All right? Any questions about that? So now the next one is the same basic idea, but the information, the type of information is different. In the first problem, we were given averages and SDs. Okay. In this second one, we're taking a sample of residents and we're figuring out how many males there are. And in Castledale, 80 out of 144 were male. And in Orangeville, 117 out of 225 were male. Well, I need to turn these into percentages. 80 divided by 144, so I get 55.5%. And 117 divided by 225 gives me 52%. Now, why didn't I get an SD? I can create an SD, but why didn't they give me an SD? Well, what question were we asking? No, so when I did the survey, what did I ask? Are you male or not? Yes or no? That is a qualitative situation. It's not a number. So before I asked, how many pounds of food did you eat? And that was a number, and because my result was quantitative, then I can find the SD of that list. Right? I have a whole bunch of numbers. I crank out the average and the SD. In this case, I'm asking a yes or no question, or I guess male or female question, and my results are just yeses or nos, and I turn those into percentages. And because of that, there is no SD. We have to make it ourselves. So we do the square root of 0.55 times 0.45, and that's going to be 0.49. And then over here, I do the square root of 0.52 times 0.48, and that's also going to be 0.49. It's probably not going to matter. Okay? So now I do the SE difference by squaring and adding them together. So square root of 0.49 squared plus 0.49 squared. And I get 0.693. What did you get rounding it to 0.5? It's really close. I got 0.693. Oh, wait a minute. Wait a minute. Hey, stop me, guys. Don't let me do that. I did it wrong. So 0.49 and 0.49. Now I need to divide this one by the square root of 144. I need SEs. And that gives me 4.08%. And then 0.49 divided by the square root of 225 is 3.26%. Now I square those and add them together and take the square root. That looks a lot better. 4 squared plus 3.26 squared. Okay, now that gives me 5.22. And Dax asked a really good question. When I calculate this, I get 0.0408. And then similarly on the other side, I get 0.0326. Do I need to convert them into decimals and then create the SE difference? Do I convert the decimals into percentages and then do the SE difference just like I did? What if I don't? What if you plug the decimals into the SE difference formula, then at the end you just convert it into a percentage and it's going to work either way. It doesn't matter. Basically all you're doing is moving the decimal 2 places. You either do it before on both of them or you do it after on the answer, and it turns out it doesn't make any difference. Okay, so now I have to look at the actual difference. Okay, so this is my standard error for difference. What is my actual difference? 3.5%. Right? So 3.5 divided by 5.22 gives me a z-score of 0.67, which gives me a p-value of, what is it? 25%. I got 0.67. What did I do wrong? Oh, no. No. You have to compare the percentages. So that's a really good point. Can I compare 80 to 117? No, those are numbers, and they have different denominators. So that doesn't work at all. You have to do the percentages. Caitlin, where are you stuck? Did you get this? The SE difference, 5.2. Okay, so now what is 55.5 minus 52? It's a difference of 3.5. So Orangeville has 3.5% fewer percentage points fewer males than Castledale does. So we take that 3.5 and we divide it by 5.22, and we get a z-score of 0.67, which means we're only 2/3 of an SE higher than the expected value, which means this area is 25%, which means we accept the null and we say we have no statistical difference between the amount of males in Castledale and the amount of males in Orangeville. Okay, now that's kind of surprising, 3.5%, but our draws are small, right? We didn't talk to a lot of people, which is why it didn't work. If we would have talked to 2,000 people, we probably would have come up with a significant difference. Okay, accept the null. The height of 100 women in Colorado and 196 women in Utah is taken. So this is Utah and this is Colorado. We get 54.5 with an SD of 3. And over here we get 53.7 with an SD of 2.7. So I need to divide this one by 10 and divide this one by 14, which is the square root of the draws. So obviously this one's going to be 0.3 and 0.1928. Now, do I need to convert these into percentages? No, this is an SE average. So the SE average, you don't need to convert to percentages. Now we do the square root rule. So the square root of 0.3 squared plus squared. And I get an SE difference of 0.356. So what that means is, if these two states are the same, when you and I do samples, I sample Utah and you sample Colorado, we should get about the same number, give or take 0.356. Well, the samples have happened, and the difference between them is actually 0.7 inches. So we expect to get exactly the same numbers, but we ended up with 0.7 as a difference. So I take 0.7 and I divide it by the answer, and I get a z-score of 1.96. Okay, which is about 2. How much area is there to the right of 2? Well, 68 is 1 SE, 95 is 2 SEs. So how much is to the right of 2 SEs if the middle is 95? 2.5. So my p-value is close to 2% or 2.5%. Is it likely for you to take a sample and me to take a sample and end up with a right tail of 2.5? No. So we reject the null. Reject the null. We accept the alternative and we say women in Colorado are shorter than in Utah.